Okay, 3 more examples. Law of Sines Ambiguous Case. So this is where we're given we're given 2 side lengths and 1 angle, and the angle is not the included angle, right? So here we have the measure of angle A is equal to 114 degrees. So this is an obtuse angle. Remember, in a triangle, you can only have 1 obtuse angle. You cannot have 2 of them, right? Also, we're given side length AB. So this is a side that's going to be opposite angle C, and we're given side length BC. That's the side opposite angle A. So you could draw the triangles. We're going to go with understanding which sides are opposite which angles. So BC, again, is the side opposite angle A. So I want to start then with the sine of angle A, which is 114 degrees, over the length of the side opposite it, which is segment BC, so that's over 12. This is equal to the sine of angle C, which is what I'm trying to find, over the length of the side opposite angle C, which is side AB, so over 34. So what this means is in order to isolate the sine of angle C, I'm going to multiply both sides of the equation by 34. So the sine of angle C is equal to 34 times the sine of 114 degrees. And all of that is divided by 12. Now you could do some reducing and all of that, but you're going to use your calculator anyway, so we're just going to leave it like this. So what we know then here is that the sine of angle C is going to be approximately, and that's what we're going to find out. So let's pull up a calculator. Let's move the calculator so that we can see our problem. And then we're going to type in 34 times the sine of 114 degrees, close that parenthesis, divided by 12. This is approximately 2.58, right? This number right here, the 2.588, that is greater than 1. Remember that the sine of any angle has to be a number between -1 and +1. So it is not possible for an angle to have this size, or for the sine of an angle to be this size. So if it's not possible for the sine of C to be equal to this number, then that means that this is not a possible, there is no solution to this. So that would be approximately 2.589, right? There is no solution because this is not possible. The sine of any angle theta, right? It has to be between 1 and -1, and this is not between, right? Not between -1 and 1. So there's no solution to this, right? Okay, let's go on and do number 11. So again, I'm given an angle measure. Angle B is 47 degrees. Angle B is opposite side AC. So I know that the sine of angle B over side AC is equal to, I want to find the measure of angle A. So this is going to be the sine of angle A. And that has to be over side, what? It can't be over side AB, can it? No, this would have to be over side BC, which means that before I can even find the sine of angle A, I'm going to have to find the sine of angle C. Because the sine of angle C will be over side AB. Right? So it's important that you're making sure that you're marking everything up. Sometimes you have to find something else before you can find what you're asked to find. So when I look at this, I'm given enough information for this ratio, the sine of angle B over segment AC. I'm given that, and I'm given enough information to find side or angle C. So before I can find angle A, I'm going to have to find angle C. So this is where we want to start. All right, so what does this equation look like then? Whoops, sorry, using the wrong tool here. So let's go back and get the pen. All right, so we have the sine of 47 degrees divided by the length of segment AC, so that's 26, has to be equal to the sine of angle C divided by AB, which is 33. Okay, so what we know then is that the sine of angle C has to equal 33 times the sine of 47 degrees divided by 26. So we pull up our calculator and move it so that we can see what we're looking at. We're going to type in our 33 sine 47 divided by 26. Okay, this is a number between -1 and +1. So this is a possible, right? This is possible to have this angle measure. So this is the first thing that we're going to check then. So we have approximately, well, we're going to use this and we're going to do the inverse sign of this now, right? So we're going to do second and inverse, right? Second sine, so that's our inverse sign, and we're going to use that answer that we just got. So second, and then the negative, so our answer, right? Close our parenthesis just to be clear. And then, so approximately 68 degrees. This is what we're saying that the measure of angle C is. Approximately 68 degrees, or 68.2 degrees, we could say. So C is approximately 68.2 degrees. That's what we're saying. Now we need to double check and make sure that that's even possible. And remember, there is that C prime also. So C prime would be 180 minus 68.2. So let's see if that's possible. So we do 180 minus 68.2, right? Okay, and that would be 111.8. All right, so now first thing we want to do is find out, is it possible, right? So in other words, is 47 plus 68.2 less than 180, right? So that's the first thing we're looking at. So back up our calculator. We have 47 plus 68.2, okay, that is less than 180. It's 115.2. So that's possible. Now, if that's true, right, then we're going to take 180, subtract 115.2, and that's going to give us the measure of angle A. So in other words, we don't have to go back and use the law of sines and the law of cosines again. We found angle C, so now we can use this to find angle A. So 180 minus the 115.2, 68.4 would be the measure of angle A. Sorry, 64.8, right? So here's what we know then. If this is true, this is, right, then the measure of angle A would be 64. Was it 64.8 or 68.4? Ladies, you know my memory goes. 64.8. Okay, so this would be 64.8. And of course, it's an approximation. So here's one measure that we could have for angle A. Now, the other thing we have to check is this. We have to go back and check if angle C is 111.8. In other words, does 47 plus 111.8, is that less than 180? That's the next thing I have to check. So I'm going to pull up that calculator again, and I'm going to add 47 plus 111.8. Well, that's 150.8. So that is possible. So that means that we do have two possible triangles that we could use. Now, if then the measure of angle C is 111.8 degrees, what is the measure of angle A? Well, we know what the measure of angle C and the measure of angle B are. That's the 158.8. So we use 180 minus 158.8. And this tells us that if angle C is 111.8 degrees, then the measure of angle A is 21.2 degrees. So in this case then, the measure of angle, and we'll call this the measure of angle A prime, because we're using C prime, right? So then that means that the measure of angle A prime is equal to 21.2, sorry, is equal to 21.2 degrees. So in this case, there are actually two different triangles that we could create. One triangle has side or angle measures of 47 degrees, 68.2 degrees, and 64.8 degrees. And the other possible triangle has angle measures of 47 degrees, 111.8 degrees, and 21.2 degrees. Okay, now you might want to rewind the video and watch that part over again, but let's try question number 12. So in question number 12, we're given the measure of angle C is 73 degrees, and the length of the segment opposite angle C is 8, because that's segment AB. We're given the length of segment BC, which is 17, and we want to find the measure of angle B. This 17 is not opposite angle B, right? Because segment BC is actually opposite angle A. So this means that, again, we're going to have to find angle A before we can find angle B. So we're going to start then, right? We're going to go straight into the problem. So what we have then is that the sine of 73 degrees, and while you're doing this, you might want to pause the video and go ahead and draw out the triangle and make sure that you're understanding what I was saying there, okay? So the sine of 73 degrees over the side opposite, so that's segment AB, that's 8, is equal to, right? We're given segment BC, that's 17, that's across from angle A, so this has to be the sine of angle A in the numerator. So to solve for the sine of angle A, I want to multiply both the numerator or both sides of the equation by 17. So the sine of angle A is equal to 17 times the sine of 73 degrees divided by 8. So let's pull up our calculator again. We're going to just check. Oops, sorry, pulled up the wrong thing. Let's pull up that calculator. Here we go. All right, so the sine, or 17 times the sine of 73 degrees, close that parenthesis, divided by 8. That's equal to 2.03. That means that we can't find the sine of angle A, right? In other words, the sine of angle A would have to equal 2.032. You can't find that. 2.03, etc. Now look what happens if I put this in my calculator. If I tried to do the inverse sine of this, 2.03, and I should have just done the answer part, right? So let's just clear that. Let's try that again. The inverse sine, right? And then stick in that answer. And look what happens when I try that on my calculator. I get an error, right? The domain is wrong. In other words, this is not possible. The sine of angle A would have to be a number between -1 and +1. If it's not, then there is no solution. So our answer to this is that there is no solution. Okay, as always, if you have any questions, please don't hesitate to let me know.